Hi, this is Dr. Sridevi welcomes you to the third topic, preparation of acetanilide using green technique. This is a technique where we apply the greener procedure compared to the conventional procedure. It is the experiment which is mainly taken into the consideration of undergraduate level students. So let us start how we can prepare the acetanilide using the greener technique compared to the conventional technique. Acetanilide preparation comes under the category of acetylation of primary amines. Acetanilide was first aniline derivative, serendipitously found to possess analgesic as well as antipyretic properties, and was quickly introduced into the medical practice under the name of antifebrin by A. Khan and P. Hupp in 1886. Because of its toxic effects, it was withdrawn from the market and prompted for the search of less toxic aniline derivatives such as phenacetin. After several conflicting results over the ensuing 50 years, it was established in 1948 that acetanilide was mostly metabolized to paracetamol in human body, and it was the paracetamol that was responsible for analgesic and antipyretic properties. The observed methanoglobinemia after the acetanilide administration was ascribed to the small proportion of acetanilide that is hydrolyzed to aniline in the body. Acetanilide is no longer used as a drug on its own right, although the success of its metabolite paracetamol is well known. Before starting the preparation of acetanilide, one should know what are the applications of acetanilide. Besides being analgesic and antipyretic, acetanilide is also used as an inhibitor of hydrogen peroxide decomposition and used to stabilize cellulose ester vanishes. It has also found uses in the intermediation in rubber accelerator synthesis, dyes and dye intermediate synthesis and camphor synthesis. Acetanilide is used for the production of 4-acetamidobenzene sulfonyl chloride, a key intermediate for the manufacture of sulfa drugs. Acetanilide is also used as a precursor in the synthesis of penicillin and other pharmaceuticals. In the 19th century, acetanilide was one of the large number of compounds used as experimental photographic developers. Now let us see what is the conventional procedure to synthesize acetanilide. Usually, acetanilide is synthesized using aniline and acetic anhydride in the presence of pyridine and dichloromethane. Before starting the experiment, we need to concentrate on certain safety features. Aniline is toxic and can be absorbed through the skin. Use in the fuming cupboard. Concentrated HCl can cause severe burns. Be careful. Acetic anhydride is lacrimatory, so protect your eyes. These are the simple safety features we have to consider before starting the conventional procedure for the synthesis of acetanilide. Let's see the procedure in detail. Take 60 ml of water in a 100 ml Erlenmeyer flask. Add 2 ml of concentrated HCl with mixing. Now the next step. It should be performed in a fume cupboard. Add 2 ml of aniline and swirl the mixture. If the solution is colored, add small amount of decolorizing charcoal. Swirl the mixture for about 1 minute and filter off the carbon using fluted filter paper. Now in a separate container, dissolve 3 grams of sodium acetate in 10 ml of water. Warm the anilinium chloride solution to 50 degrees centigrade on water bath. Add 3 ml of acetic anhydride. Swirl to effect dissolution and add aqueous sodium acetate quickly. Swirl the flask a couple of times and set it in an ice bath for 20 minutes. Filter with suction the crystals of amide formed and wash with a small amount of ice cold water. Continue to apply suction to Buchner funnel for a few minutes. Dry the material between the filter papers and submit your sample for assessment. determine the yield and melting point of your product. So now let us see what are the non-green components from the conventional procedure. We have utilized CH2Cl2, that is nothing but dichloromethane, which is toxic. Pyridine, which we have used, is also not eco-friendly. Acetic anhydride leaves one molecule of acetic acid unused, so it is not atom economic. So these are all the non-green components from the conventional technique. Now we have entered into a green procedure. In this procedure, we are going to synthesize the same acetanilide but in a different method. We are going to use the same starting materials, like suppose aniline and acetic acid, but in the presence of zinc dust and boiling. The basic chemicals required are aniline, glacial acetic acid and zinc dust. Aniline we take 10 ml, glacial acetic acid we take 30 ml and zinc dust we take 0.5 grams. We can start our experiment using these three materials. Now let us see the procedure in detail. A mixture of aniline, zinc dust in acetic acid in a 100 ml RBF, that is nothing but round bottom flask, was heated over a gentle flame using water condenser. Heating was continued for about 2 hours. The reaction mixture was then carefully poured in cold water in a 250 ml beaker with cooling and vigorous shaking or vigorous stirring. The shining crystals of acetanilide were separated slowly. After 15 minutes, the acetanilide crystals were collected by filtration. The solid crystals were washed over Buchner funnel with water and the product was dried. The product is now recrystallized using boiling water, and then it is kept for drying and then determined for the melting point and also the percentage yield. Here we end the procedure of green synthesis. Let's see what is the green context in this procedure. First is it avoids the use of acetic anhydride, which is usually banned in some states and due to its utility in narcotic business. It also minimizes the waste byproducts, also avoids the hazardous solvent. So definitely this technique is better than the conventional technique. Here we go for the mechanism how the acetanilide is produced from aniline in the presence of zinc dust and acetic acid. In this mechanism, we observe the acetylation of primary amine. The primary amine used is aniline. So on acetylation using acetic acid, we get acetanilide. From today's topic, we have learned how to synthesize the acetanilide using the greener technique. From today's topic, I hope you apply this technique to the UG level students when you go for the experiment in your common laboratory. And I wish all the best. Thank you.